Hey everyone, Jared VK3BL here, and first of all I'll admit the title of this video is somewhat provocative, and I've done that intentionally, not to really, I guess, call anyone out or anything like that, but just to draw attention to the fact that the IC9700, sorry, is a radio that I guess is really prime for criticism. And the reason I guess it's prime for criticism is that it's a very high frequency and ultra high frequency radio. And as most hams have been in the hobby for some time will know, the higher you go in frequency, the harder it is to get, I guess, things like frequency, stability, dynamic range, parameters that we often talk about on HF radios. But it's also harder to measure those things. And that's really what I want to draw attention to today, because what I've seen in social media over the last couple of weeks is there's been reports that from Germany and from Australia that, for instance, the IC9700 isn't stable. Now, you've got to ask yourself, what does isn't stable mean? And that's sort of really the first point that I want to make and I want to talk about. And I'm also going to cover why my radio, generally speaking, doesn't provide measurement data. Now, everyone's probably familiar with Rob Sherwood. He's got a list of, what's considered the golden list of transceivers, which ones have the best dynamic range or close-in dynamic range. These are transceivers that are good for contesting work, that sort of stuff. And he ranks them all according, from best all the way down to, basically a Yaesu FD101 Echo, which, by the way, you can still easily make a DXCC with a 101 Echo. So, you might see the dynamic range of 60 and think, oh, I can't do anything with the radio. Well, the fact of the matter is that's how I got my DXCC, and generations of hams did. So, numbers aren't everything, but they are something, and basically I just want to talk about what numbers mean, what they should mean in ham radio, and the quality of measurements that we can make as amateurs regarding radios. Now, what you will have noticed on my channel is that I often do IMD tests of receivers, and that's basically to see you run two tones through the radio or the human voice, and then I run that into a dummy load and I sample it with, I have a sampler in place and I use a SDR play. In this case I'm using I would use a RSP Duo SDR play. Lovely little device, and that gives me really accurate data in terms of a two-tone IMD test. And why am I confident with putting that data out, but I'm not confident with putting other statistics out? It's because I've looked up the design of this device, and I know that for the actual ADC chip that's in here, the analog to digital converter, the target market for that design was actually decoding digital television. Now, basically, in a nutshell, digital television uses a form of modulation called orthogonal frequency division multiplexing, and it uses constellation sizes up to quadrature amplitude modulation 256. Blah, 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 blah. What does that mean? In a nutshell, it means the peak of the signal to the average power ratio is 10 decibels, and that means, amongst other things, that the tuner in this little box here, it has to be able to tell the difference between 1 decibel and another in terms of relative to each other. So a signal's coming in, it's got to be able to tell, in order to decode that television signal, whether or not the following signal is a decibel stronger or a decibel weaker, or maybe more. As I said, there's a 10 decibel dynamic range than the preceding ones. Now, that means that given the chip in this, and given the application and the fact that it works mass produced, I am really confident that this device can accurately measure whether a transceiver, for instance, has a IMD3 of 30 dBs, 30 decibels below a single tone. And that's because I know the design of this device. I know what it was made for. I know its limitations. And another thing is, if you go to the manufacturer's website of the RSP Duo, well, SDR Play RSP Duo, I always get that wrong. Love the product. If you go to their website, and excuse the lighting, I've tried to make the computer screen invisible. They give you the full specifications of the product. And if that's not enough for you, there's even a more detailed specification sheet. And, you know, it covers everything such as the sensitivity, you know, the gain, you know, the gain you can get out of it versus frequency, just basically everything under the sun that you might want to know. So, you know, I'm really happy to go and get my HF transceiver out, run 2 tones into it, and say, yes, this transceiver, this Icom 7610, it's 30 decibels down at full power. It meets Icom's published spec, because I know that I am providing people with accurate information. As well, especially in the case of the, or most importantly, in the case of the radio I've got on my desk. Now, this is another topic that I'll get into, but you know, I can say that yes, the IC7610 I've got here, when measured with a device that I know is designed to provide accurate data down to about a decibel, it does meet its spec sheet. So I'm just scrolling through and showing you just how much information SDR Play give on their product here. And that's one of the reasons I'm such a big fan, is they tell you everything about it. Now anyway, that's a bit of a digression. What does all this have to do with the IC-9700, you might ask? Now, there's been quite a few people saying the frequency stability isn't perfect. For instance, I've seen claims that on the 2 meter band, the frequency varies by up to 30 hertz. And let that sink in, 30 hertz. You know, so you're transmitting at 145 megahertz, for instance, and your carrier might deviate 30 hertz back and forth over a period of time. The period of time I saw quoted was 4 minutes. Now, is that good or bad? I'm not sure, but there's much more to discuss than whether or not that's good or bad. The point is, I've seen that claim. Now, you might think to yourself, well, the SDR Play, the RSP Duo I've got here, that's rated to 2 gigahertz. Why don't I just plug that into my dummy load, which is also rated to 2.5 gigahertz or something like that? Why don't I hook that all up, key up a carrier on my lovely 9700 there, and use this device to test the frequency stability? And, you know, put those claims to the test. You know, there's a guy out there publishing information saying it deviates 30 hertz on 2 meters and 300 hertz on 23 centimeters or 1.2 gigahertz. You've got a 2 gigahertz rated tester here, Jared. Why don't you go and test that claim? And the answer is quite simple, and this relates to why I don't publish a lot of statistics. It's because while this device is accurate to a decibel in terms of signal strength, now I mean relative signal strength. You know, if I plug this in and it reads negative 30 dB, I'm not confident that that's exactly negative 30 dB. I'm just confident that if I turn the power down by half, it'll read negative 33 dB. So another aside, this is a very complicated topic. But while I'm confident this can accurately measure the IMD performance of a transceiver, its design goals were not to have, you know, absolute perfect frequency stability. Now you can put in a 24 megahertz reference clock to it to increase the frequency stability if you want. But when we're talking about something like 1.2 gigahertz, you know, we really are talking about something that is very hard to measure. And if I was to go and connect all of this up, I am sure I would see the radio deviating from the exact frequency that I've set on the screen there. I'm absolutely certain of it. And why am I certain of it? Simply put, because my measurement device here well, I don't know the exact numbers, but basically it costs a tenth of, not a tenth, but maybe an eighth of the radio. Now, while the cost of something isn't a perfect way of determining how good it is, generally speaking, when it comes to test equipment, the more you pay, the better you get. And I'll show you an example. If I did want to measure the frequency stability on the IC-9700, I'd probably want to go for something designed to measure frequency. So I'd want to go for a piece of test equipment, and bear in mind, while I can use this as a test equipment for bit of test equipment for some things, such as dynamic range testing, this isn't a bit of test equipment. This is made as a general purpose receiver from low frequency to 2 gigahertz. I forget the spec sheets, right? It's made as a receiver. It's not made as a bit of test equipment. It does happen to function quite well as a bit of test equipment in some cases, and I know which cases they are because I've looked up the chip in it and I've looked up the standards that chip's meant to decode, but it's still not a bit of test equipment. So if I did want to measure the frequency stability at 1.2 gigahertz of the IC-9700, I'd probably go along and go to my local electronics supplier, and I'd go, sorry about this, I've got a dry mouth, it's quite hot here in Australia. It's better. I'd probably go to my test equipment vendor and I'd say, hey, I've got this problem. I need to measure the frequency stability of something at 1.2 gigahertz. What do you recommend? My budget's not unlimited, so don't give me the $100,000 super model that does everything. I just want to measure the frequency. And they'd probably turn around and say, well, why don't you go for the Roden Swartz Hotel Mike HM 8123 frequency counter. And bear in mind, this is a device, and all it does is display the frequency on the screen. You know, that's all it does. I mean, in terms of its design goals, obviously it has a bunch of other features here. I think I've got a bigger photo of it there. You can see it's got a whole bunch of buttons on it, 2 inputs. I'm sure it does more than display just the frequency, but its sole purpose in life is to provide very accurate measurements of frequency. Now, I'd say, okay, sweet, well, you know, yeah, let's go for it. Let's go and get that frequency counter. It's a bit of test equipment from a reputable manufacturer. Its sole purpose is to provide me with a very accurate measurement. What's it going to set me back? And they'll turn around and they'll say, that's 3,000 Australian dollars, please. Now, that's more than I spent on the IC-9700. And the IC-9700 does a whole lot more than just count frequency. You know, it can transmit. It's got, you know, it's got heaps of features in there. My next video is going to be a list of all the features. But the point being is, it is horrendously expensive to buy a frequency counter that's capable of providing accurate data at 1.2 gigahertz. So when I see that and I say to myself, well, there's an amateur doing measurements. Well, my first question is, and this is what your first question should be, what is he doing the measurements with? Or what are they doing the measurements with, I should say. And in this case, the measurements were being done with another Icom radio, an IC-9100. Now, it was locked, GPS disciplined, apparently, using a reference input. But once again, who made the GPS discipline device? You know, when you connect that up to an IC-9100, what do you expect to be its stability? All these sort of questions. But most glaringly, the point is, we're testing a transceiver with another transceiver. We're not actually testing it with a dedicated bit of test equipment. So for me, that immediately says, well, is it the IC-9700 that's deviating from transmitted frequency? Or is it the IC-9100? Or at 1.2 gigahertz, is it the way you've got things hooked up in your shack and power supply variation, or a number of other factors which could affect measurement? Measurement is a real art, and I mean that in the sense that when someone calls a scientific topic an art, they mean that it's a really, really hard thing to do. Like, you know, so to produce accurate scientific measurements, just measurements, is very, very hard. And you know, that's why a calibrated bit of Rode and Schwartz equipment, and I'm guessing that's probably the entry-level model looking at the spec sheet, is $3,000. So when someone says, oh, well, I'm measuring with a transceiver, the gist is it the 9700 that's off, or is it the 9100 that's off? That's the first question you've got to ask. Now, the second question you've got to ask is, how many units did you measure? So let's just say I went and bought this nice Rode and Schwartz frequency counter, right? And I measured my 9700. And let's just say it was 500 hertz, so half a kilohertz, 500 hertz off at 1.2 gigahertz. And I thought, geez, that's no good. I'm going to go and write on the internet, that's no good, this is terrible, blah, blah, blah. I tested it with just like Jared said, I tested it with, you know, a dedicated bit of test equipment, this radio, it's just no good, yada, yada, yada. You get the picture. No one's done this, so I'm not saying, I'm not trying to be nasty or anything like that. I'm just trying to, I guess, bring up the topic of critical thinking and that sort of thing. There's a lot of value in doing measurements, but you need to understand what you're measuring and how you're measuring it. So anyway, back to the topic. Let's just say I go on the net and say, well, my IC-9700 on my Rode and Schwartz deviated 500 hertz. And these are completely made up numbers. I don't have the Rode and Schwartz. I'm never likely to have one. I can't justify it. And anyway, well, the fact of the matter is that's one radio. How do I know that my IC-9700 isn't faulty, or that I didn't make some measurement error? I don't have a history of working in measurement and instrumentation. You know, that's not my profession. Doing lab grade measurements is not my profession. So a one-off measurement, what's my certainty that that's going to represent the product? Well, it's actually exceedingly low. Now, I would wager that when Icom were developing this unit, they got the initial 100 or 200 or more, and they tested them all. And when they tested them all, there is going to be deviation. The fact of the matter is, at very high frequency, unless you want to pay hundreds of thousands of dollars, when I say very high frequency, I mean UHF, I actually mean, you know, 1.2 gigahertz. Unless you want to pay a really high price tag, not an amateur price tag, you are going to get frequency instability. It is a fact of life. Look, we all remember the days of FT101s, or when someone comes up on air on HF, and, you know, we're tempted to say, oh, you're 100 kilohertz off, 100 hertz off frequency or something. Well, that's just the way it was back in the days. No one was perfectly on frequency. People had to, you know, tune in. That's why we have a RIT knob on our radios and a XIT or TX knob. It was a normal thing back on HF. We've gotten to the standard now where HF radios are really very stable. But, you know, the challenge still is there to produce at a cheap price. And I think the IC-9700 is very cheap for what it is. You know, a completely stable radio. You know, it's an impossible goal. We can make better, we can have worse, but we can't make perfect, you know, in the amateur world. So what I'm trying to say is, just say I measured mine at 500. Well, that's only one radio that's been measured. That's not the 100 or 200 that Icom have measured. Now, when they've done that, when they were designing this product, their engineers would have measured them all, and they would have plotted it on a bell curve. And a bell curve is a standard statistical, I guess, a graph. It's not called a graph, but I forget the name anyway. Well, it's a curve, right? And it's used for a lot of statistics. Statistics is something that I have been educated in. So you know, it's been a while since I've actually done any statistical analysis, and I'm not a great mathematician, but I do understand the concepts and the philosophy behind it. So Icom would have gone and tested, you know, let's just say 100 units with their, you know, not entry-level Rode and Schwartz, probably something way better than what, you know, I can afford or most hams could afford, and they would have drawn a graph, and they would have plotted the results of all the IC-9700s, and they would have figured out what the mean is, and they would have gone, yes, over our production run, that is acceptable for what hams are going to do with the radio. We've designed a good product. you know, the faulty one that Jared got at 500 hertz deviation at 1.2 gigahertz, that's way out here in the outliers. Unfortunately we can't avoid that, but you know, if it bothers Jared, he'll send it back under the really generous 5-year warranty that we have in from Icom Australia. So we would have gone ahead, sent the production order off to the factory and said, yep, go and make them. We're really confident that the majority of radios are going to sit there. Now, I'll give you an example of where the idea of testing a single radio has, you know, basically made someone who's really good at testing look a little bit silly. And that's Rob Sherwood. And everyone who's interested in receivers, let me see if I can pull that up here. A little bit uncomfortable the way I'm working. I'm unfortunately right-handed when it comes to using mouse. No, that's not the right Sherwood. So Rob Sherwood's gone, and here's his nice ranking. Now, if you look through some of the latest rankings, you'll find he's tested 2 different transceivers and gotten vastly different results. So even though Rob Sherwood has, you know, probably decades of experience of testing amateur gear and its performance, and he used to make kits to increase the performance of transceivers, you can see from his own published data that his methodology was flawed simply because he was only testing 1 transceiver. When he started testing 2, he found out all of a sudden that they didn't test the same. And that's pretty, for anyone, I guess, versed in statistics, that's an obvious fact. We always know that nothing is identical. Aside from assembling something with, you know, on a nano scale with nanobots that haven't been invented yet, we've never been able to make anything identical, and radios are no different. So once again, that's it sounds like a rookie mistake to only test one radio and then make claims about it. But even the, I guess, most respected, most viewed source of test data was making that particular mistake of only testing 1 sample. And so I guess they're the 2 main flaws that you'll see people come up, and unfortunately, because it is a UHF radio going to 1.2 gigahertz, it will be prime for people, I guess, picking on its performance a little bit, saying, oh, it's not 100% stable on frequency, or you know, whatever sort of any technical measurement you can make. This is, you know, it's going to be flawed in an amateur context, I guess. So it is a radio that's going to be prime for not misinformation, because the information isn't wrong. It's just not necessarily right or accurate, and it might not apply to the, well, it almost certainly won't apply to the radio you buy. So what Rob's tested a radio at, it's not going to match up at 1.2 gigahertz with the one you've got sitting there. It's as simple as that. It's just not, even if you use a perfect kit. And that's because every sample is different, which, as I said, he's recently learnt because he's testing multiple units now. So this is a bit long-winded, I am sorry, but basically we've covered that, 1, it's very hard to measure some things, and when you do measurements, you want to make sure you're using a bit of you're using appropriate equipment. You're using a bit of test equipment that is designed for that purpose, and you know its accuracy. And 2, you want to measure more than 1 device. Now, I want to say something more broadly about the IC-9700, and that's that one of the things that I can't seem to get a good answer on, and I've asked, you know, the IC-9700 forum and on Facebook and all of that, is, well, yeah, we're seeing these, and I'll call them amateur measurements coming out about the radio, but what does it mean? And by that I mean, yeah, okay, let's just say we accept that the frequency stability is 30 hertz at 2 meters, right? Let's say we accept that, even though we've only measured 1 unit with another radio, which isn't a bit of test equipment. Just really rubbing that, trying to get that point across. So we've accepted that, right? But is that good or bad? I mean, has anyone gone and tested the IC-9100, or have they gone and tested the IC-91H, or IC-910H, or the IC-970H, or any of the older generation 1.2 radios? What's the data like for those? And I haven't been able to get good data. So I guess what I'm saying is this is the latest and state of the art for the ham budget, and it's fantastic value. Now, it's one thing to provide a critique, but if you don't know what you're measuring it against, and in this case we're measuring it against the previous products on the market, how do we know if it's good or bad? The answer is we don't. Until we compare what this radio is like to its predecessors and we have accurate data, we can't make any judgments about it. We can, and I don't think we're going to get the kind of data that I'm looking for. I don't think we're going to get 100 IC-9100s all tested with a Roden Swartz frequency counter. I just can't see that happening, much less a bunch of IC-970Hs. But what we will find is that as people get these units and they use them in things like field day or to drive transverters, and they've replaced their older equipment, they'll give us feedback as to whether they're having a more enjoyable experience, because ultimately that's what it's about, or a less enjoyable experience. Oh, sorry, got a cramped foot there. So in my mind, if you're worried about is this the best radio, is this the best 1.2 gigahertz transceiver that's ever been released, if that's your concern, wait till the field day guys start using them for activations where they're in low noise environments, running dedicated antennas, trying to set distance records on 2 meters and all of that, and get your feedback from them. Because ultimately, that's the valuable feedback, is, when we're trying to compete for distance records, or in a VHF contest or a UHF contest or whatever it is, does this radio provide us with an advantage? That's really what we want to know. So if that question is burning on your mind, don't worry about a report from Germany or a report from Australia, or basically what I call, and I don't mean this with any offence at all, but amateur measurements, because they're measurements done by amateurs. Don't worry about that. Worry about the real life performance of the radio, what it's like. Now, I'll just go on and I'll say one last thing, and this might rub the point home. Now, I have some of my friends who I'd count as Elmers are quite active in the, sorry, I'm just dropping my recorder there, are quite active in the transverter scene, and they'll run, I think, up to 24 gigahertz, one of my friends has. Now, what does he drive his 24 gigahertz transverter with? A Yaesu FD817. Now, this is an 818, but, same radio, basically. Now, I can tell you right now, compared to an IC-9700, this thing is the least stable, lowest dynamic range radio you can possibly lay your hands on. And at the end of the day, he makes heaps of successful contacts. He really enjoys the hobby. And I know for a fact there's a lot of transverter users out there who are driving their transverters with FD817s. And they're nothing special. They're like a 20-year-old design. A modern radio blows them out of the water. But these guys are still using them, and they're using them successfully, primarily because the 5-watt maximum output basically guarantees they're not going to blow up their transverter. So they've been exceedingly popular in that use case. Are they the best HF radio or transverter driver? They're a convenient transverter driver. Do they have the best dynamic range? Heck no. I reckon it'd be around 60. Are they the most stable radio? Not at all. But it doesn't matter for what people are using them for. So the way I look at it, if I've got a bunch of microwave enthusiasts all having a fantastic time on field day, setting records and stuff like that, with the Yaesu FT817. An IC-9700 is going to be a game changer. Now, one of the lovely things about the IC-9700 is that you can limit its power output, put a hard limit in there, so you can go and limit it to 5 watts. And the preliminary test data, and once again, this is amateur test data, but this is data I have more faith in, shows that when you limit it to 5 watts, it actually stays at 5 watts. So all indications are that this is going to be a phenomenal radio for field day and transverter work. So I wouldn't let, reports worry you. Another example, Rob Sherwood here on his chart measured the IC-9700. He measured 1, and he came up with a dynamic range of 74 dB. I actually spoke to Icom Australia, and Icom Australia escalated it to Japan, and I asked about this measurement, and the response from the Japanese engineers were the main priority on the 9700 was actually gain, so that you could hear the other signals, but that according to their own internal tests, they were getting better figures than 74 dB dynamic range. So once again, do you believe the manufacturer? Do you believe Rob Sherwood's test data? Well, in this case, I'm probably going to go with the manufacturer, just because Rob's tested 1. Icom, I'm sure, would have tested at least 100, or they would. In statistics, you basically figure out how many units you have to test for it to give you an accurate confidence interval. So Icom would have figured out, doing their test, 100 units, 200 units, whatever. They would have tested that amount of units, and on average, they're getting better than what Rob Sherwood's claiming here. Now, the other thing I'll point out about this table is it makes absolutely no sense to put a VHF and UHF radio amongst a list of HF radios. It doesn't make sense. Like, for instance, you can go and look up the IC-7100 or FT991, and I can guarantee you the 9700 most likely outperforms them on 2 and 70, but the results probably look similar. And that's because the test data doesn't actually specify whether they've tested those radios on HF or whether they've tested them on VHF and UHF. And even with the 9700, that figure of 74, was that at 2 meters? Was that at 70 centimeters? Was that at 1.2 gigahertz or 23 centimeters? Was that all three averaged? Was it the mean? It's just not there for consumption. So I really don't get why it's on that table at all. I'm glad Rob measured the radio, don't get me wrong. I just don't know why he put it on that table and why he didn't supply a little bit more information. So the general gist of it is, if you're sitting on the fence with an IC-9700 and you've seen some, critiques out there saying, oh, it's not frequency stable, oh, it doesn't have enough dynamic range or whatever, just remember, just look into these reports and see, ask yourself, how many radio, what equipment are they using? Are they using another transceiver? Well, how do they know the other transceiver is not the one that's unstable, instable, either. And 2, ask yourself, well, how many radios do they measure? 1, I guess, because they're probably, unless you're loaded, you only have 1. And then ask yourself, well, yeah, you've got that measurement data, but what does it mean? Just say, does it mean the radio's worse than previous models, or does it mean it's better? And the answer is, I can't find a good source of data on previous models, but I do know that a huge amount of people are happy driving their transverters, even up to 24 gigahertz, using an FT817 or FT818. So in that regard, if you're interested in getting an IC-9700 to drive a transverter or to do your 2 and 70 work, I'll stake my reputation that you will be happy with your purchase, despite what some amateur measurements might show. I'm going to go with the factory on this one. I've got no reason to. That's my own personal radio. Icom don't sponsor me. They've never given me any money or anything like that. They have lent me a radio once, but when they lent me the radio, which was the IC-8600 receiver, just because I couldn't justify buying one, they basically, I had to sign a sheet saying if I broke it, I'd buy it, but there was no restrictions on what I could say. I could have brought it back to this shack and said, this is the biggest waste of money known to man, and I'm not sure they'd be happy with me, but I was under no obligation to say nice things. So my hat goes off to Icom for that. Do I have a lot of gear? Do I look biased towards Icom? Yeah, I probably do. But that's because in my mind, they've got the best warranty in Australia. It's 5 years, and I happen to work 5 minutes drive from their head office. So if something breaks, it is really convenient for me to get it fixed. So does that mean I'm likely to buy Icom? Yes, it does. Is there any other vested interests for me to say nice things about Icom? No. You know, when the IC-9700, IC-7610 had LCD issues, I published that on Rate My Radio. So I'm not obliged to Icom to say nice things. I'm just trying to present you with the facts, and the facts basically are, yes, there's some reports coming out, but we're talking about a device that works at very high, ultra high frequencies. That's going to inherently make it hard to measure accurately. It's being measured by by devices that are not test equipment. There are other radios, stuff like that. The sample size is low, only at 1, and basically that's low quality data. Now, even if we go and get all the amateur tests and we collate them all into one table and try and produce that bell curve I showed you, it wouldn't work because people aren't testing them in the same environment. They're not testing them with the same equipment, etc., etc. So I think I've ranted probably long enough on measurement and statistics. I hope you've gotten something from this, and I hope it, if you've been worried about maybe early reports out of Germany, I hope just the very fact that what people are quite happily using FT817s and they are not stable. I hope that very fact reassures you that you're going to be happy with your purchase in that regard. So if you can afford to buy one now, and by that I mean it's not going to put you out, be an early adopter, enjoy your radio. If you can't afford to, if you can just justify buying the radio, maybe wait for the dust to settle. Wait for the field day to happen and for the radio to get glowing endorsements on eham.net, things like that. If you can't afford one, and look, I really think they're a bargain given their price, they've decimated, no pun intended, if you get that joke, leave it in the comments, they've decimated the second-hand market. So, if you want to get into 270 DXing, go and pick up a 9100 or a 910 or 910H second-hand. They're cheap as chips now because of this radio. So, even if you can't afford it, you can afford to get into this aspect of the hobby, and that's VHF and UHF, DXing, that sort of stuff. Even just rag chewing with fellows on SSB locals is extremely enjoyable. So that's basically my summary. I hope it's been educational, and I hope I didn't drone on too much, but it is something I'm passionate about. I don't sort of like it when a product's released and based on one experience, the whole community basically its reputation gets tarnished. I don't think that's fair. I mean, not every, even if it was a complete failure, that's still a single unit, right? But when it's based on performance, we don't even know whether it matters, and I wager it doesn't. I don't think it's fair to put that sort of data out there, especially when it probably doesn't. The performance probably doesn't matter, and it wasn't measured properly anyway, and the statistics were wrong, weren't done properly. So I think this radio, once again, it's going to be prime for, and I say this lovingly, haters or detractors, but at the end of the day, you really do have to question these things, question them for yourself. I think you'll be happy with it. Have a lovely day. Get into 2 and 70 SSB. I want to talk to you. This is Jared of VK3BL saying 73 for Rate My Radio.